Today we are going to study the relationships between arcs and angles in a circle. In order to do this, we need some vocabulary. Our first definition is a central angle. An example of a central angle is already shown. Here is our definition. A central angle is an angle whose vertex is the center of the circle and its sides are radii of the circle. Notice center, radius, radius. Our next definition is referring to a specific arc on the circle called the subtended arc. The subtended arc is actually the arc that's defined by the central angle. It's the one that's between the radii of the central angle, or between the sides. The definition of arc measure is that the measure of an arc is equal to the measure of its central angle. Arc measure is made in degrees. It does not refer to the length of the arc, and as such, the length of the radius has no effect on it. There are two arcs shown in this diagram of concentric circles. First, I have the smaller circle, the red circle, and I have arc AB. Then I have arc CD, which is on the longer circle, and what I know is that the measure of arc AB is also equal to the measure of arc CD because they share the same central angle. Arc length does refer to the radius. You will notice in the example above that the red arc is definitely smaller than the black arc. Arc AB is definitely a smaller piece of the circle than arc CD. It's still the same proportion of the circle. So we have a formula for that, and the formula is based on the circumference of the circle. Notice part of the formula is the formula in terms of radius for circumference. The remaining part of the formula is referring to what part of the circle you're talking about. Because there are 360 degrees in the circle, if you take the measure of the central angle and divide it by 360 degrees, that will give you what portion of the circle: 1/4 of the circle, 1/5 of the circle, 1/8 of the circle. You take that, multiply it by the circumference, and that will give you the length of the arc. There are some important ideas here. One of them is that a circle will always have 360 degrees. Another one is that if two arcs are adjacent to one another, you can add them together, and that would give you the measure of the larger arc. Here's a biggie. Minor arcs are named by their endpoints, and they have to be under 180 degrees. Major arcs and semicircles also are named by their endpoints, but they must include a point in between the endpoints when we name it. Now we do have a theorem in this section. It says, in the same or congruent circles, two arcs are congruent if and only if their corresponding angles are congruent. Notice central angles. That is also important. There are other types of angles in circles. Now, basically it says if I have a circle and I have an arc over here whose measure is 30 degrees, and I have another arc over here whose measure is 30 degrees, I know those two arcs are congruent to another. Or if I have two circles that happen to be congruent, and one of them has an arc of 30 degrees and another one has an arc of 30 degrees, then those two arcs are also congruent to each other. So in the same circle or congruent circles. Now, when we name arcs, we discussed it or mentioned it on the previous page, you always name the arcs with the beginning letter, the end letter, and if it's 180 degrees, which is half of a circle or more, you need a letter on the same side. So let's look at some possible ways of naming a semicircle on here. AD is the diameter. You can tell this because it goes through the center O. that means it cuts the circle into 2 equal parts, or 2 semicircles. If I want to name the semicircle on the top right piece, I can either name it arc ABD. Notice end point, those were the end points of the diameter. The B tells me to go on the upper portion of the circle. I could name it ACD. Again, that is the same side of the circle. It's the same upper portion of the circle. So this would be that arc. It doesn't matter which endpoint you name first either. I could name that DCA or DBA. Either way, I'm referring to the arc on the upper half of the circle. If I'm referring to the arc on the lower portion of the circle, I could name that arc either arc AED or arc DEA. Notice the symbolism. You put the arc over the points that create the arc. Now, our definition of a major arc was an arc that's over half a circle. So now I'm going to be looking at an arc that goes more than halfway around. If I start at A and end at C to go more than halfway around, I have to pass through either point E or point D. I could name that arc AEC, or I could name it ADC. That's the same arc. But if I want 2 major arcs, another major arc may start at B and end at D. I could name that one either BAD, or I could name it arc BED. Notice I have the beginning point, the ending point, and one point somewhere along the pathway that I'm taking. And the point along the pathway always has to go in the middle. Now, minor arcs are any arcs that are less than 180 degrees. So if I look at these, there are a ton of choices. The only ones I can't use are anything that is greater than arc AD. And arc AD is also not included. So I could use AB, I could use AC, I could use BC, I could use BD. Notice all these choices. There are just an absolute ton of choices here. I could use CD, I could use CE, because I can see that C to E is not going to go through the center of the circle, so it's less than half of the circle. So that's why I could use CE. I could also use DE or EA. So I have a lot of choices on minor arcs. Let's look at our next example problem. This problem refers to the fact that a circle adds up to 360 degrees and the fact that a semicircle adds up to 180 degrees. Notice that RV was a diameter, which meant each side of the circle was 180 degrees. On the right side, I have some information about all of the angles. On the left side, I don't have any information about angle QTR. So I'm going to have to work with the right side of this circle. Now, think a second about what you would do to find the value of x. This actually refers to the arc addition postulate and the definition of arc measure. Each of those arcs equals the degree measure that's marked in the angle. And we know that the entire arc is 180 degrees. Therefore, I know that 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180 degrees. Pause the recording, take a moment to solve that problem, and then restart. That's right, x equals 7. Once we know what x equals, we can substitute that back in and find the value of each arc. 8 times 7 minus 4 was 56 minus 4, or 52 degrees, is arc RS. It's also angle RTS. 13 times 7 minus 3 is 91 minus 3 is 88 degrees. That accounts for arc SU, also angle STU. 5 times 7 plus 5 is 40 degrees. That accounts for arc VU and angle VTU. 20x over here on the other side of our circle then is 140 degrees. 20 times 7. So arc QV is 140 degrees. Now since that side of the circle adds to 180, that means arc QR has to be 40 degrees, so angle QTR is 40 degrees. Notice how finding x, we were able to find every central angle and every arc on the circle. One of the things that circles are used for a lot in the real world is circle graphs. You'll find them in the newspaper and everything else. You should know how to create a circle graph, and you should know how to read a circle graph. When you create a circle graph, two things are important: the percentage in each category and the percentage of 360 degrees in the circle. Those two things are the same. So when you're creating them, the first thing you do is calculate the percent for each section. To do that, you divide the amount for the section by the whole amount and multiply by 100. Then take that percentage times 360. This will tell you how many degrees go into each section of your circle graph. Draw an initial side in your circle and then continue. Do the following example and then check your work. You can check the resulting circle. Make sure yours looks very similar to that. The last thing we need to be able to do is actually use the information from a circle graph. The graph below shows the percentage of each type of bicycle sold in the United States in 2001. It says find the measurement of the central angle representing each category, list them from least to greatest. This again has to do with our degrees, the fact that a circle is 360 degrees. So the first thing we're going to do is we're going to multiply each percentage times 360. So 0.37 times 360, 0.26 times 360, 0.09 times 360, 0.07 times 360, and 0.21 times 360. After you multiply each of those, then you need to place them in order from lowest to highest. The next question is regarding the arc for the wedge named Youth, which is 26%, as opposed to the wedges for Other and Comfort. Well, if you add together the measurements or the percentages for Other and Comfort, that adds to 28%. The question then is, does 28% equal 26%? And I'm sure you understand the correct answer is no, they are not congruent. This concludes today's podcast.